अच्छा, so students, how are you? Before this lesson, we have completed the differentiation up to the differentiation of trigonometric functions, including the derivative of exponential functions, logarithmic functions, and the product and quotient rule. Today's in my lesson, we will cover the differentiation of inverse trigonometric functions and then the hyperbolic functions and the inverse hyperbolic function. Okay, let me start now how to discuss the inverse trigonometric function. I would focus only on the methods, how to attempt the question to do the derivative of inverse trigonometric function. Okay, let me start now. So then how you can find the derivative of the trigonometric function. Number one, if we have the trigonometric function, say y equals to sine inverse of x. I'm just writing the formula of the derivative of the sine inverse trigonometric. What is the formula of the derivative of this trigonometric function? 1 by 1 minus x square. And the formula for the inverse function of cosine is negative, is only, there is no much difference. It is from the derivative of sine, it will be negative 1 by 1 minus x square, the whole over. And the third formula of the derivative of inverse trigonometric, that is the tangent inverse. Tangent inverse of x is dy by dx is equal to the derivative of this thing. And then come to the derivative of cotangent inverse of x. It is exactly the same, but there is a difference of negative with it, which is minus 1 by 1 minus x square. Oh, sorry, it is plus. It is also plus. Okay. Now come to the derivative of y equals to secant inverse of x. So far as the derivative of secant inverse, it is equals to dy by dx 1 by x into the square root of x square minus 1. And similarly, the derivative of cosecant inverse of x is equal to dy by dx. So only the negative of this, x square minus. We can prove also these, but these are not necessary to be required for the proof for the exams. So I just want to put my focus on your exams questions. Now, for example, if you want to find the derivative of y equals to, that I have sine of 3x, sine inverse of 3x, then its derivative will be equals to the derivative of 1 by 1 minus 3x whole square whole under. That's it. Into, as usual rule, the derivative of the inner function, which is 3. So the differentiation of sine inverse, this you can further simplify this. It can be written as 1 minus 9x square. That's it. We have this. Now come to another example. Let we write the sine inverse function of tangent tangent inverse of square root of x. If I write the square root, always write the derivative of inner function with it. So you can write the derivative of tangent inverse. It is equals to 1 by 1 plus square root of x whole square, as in the formula. And then derivative of the inner function, which is the derivative of this, because it is x power 1 by 2, we write the power and then reduce power by 1. 1 by 2 minus 1. In the next step, it is 1 plus x into, this is 1 by 2, x raised to the power negative 1. So you can also write this in the denominator, 1 divided by, you can take this term in the denominator, this is also in the denominator, it become 1 plus x or then under root of x. So this is the differentiation of tangent inverse of this function. And these are actually 6 functions you have to keep in your mind the formula of every. Now I want to do some more examples related to the trigonometric inverse functions. So I'm removing these all writings. So look at this. If I have another question, let this is e raised to the power 2x and the sine of inverse of 3x. So by using u into v formula in my previous video, the derivative of this function, the derivative of this is 2x and into 2, keeping the sine inverse as it is, 3x plus. Now the derivative of sine inverse and keep this as it is, 2x into derivative of sine is the 1 by 1 minus 3x square, the whole square root, into the derivative of inner function, which is, and then we can simplify this by taking e raised to the power x as common, and you know the derivative of e power x was e power x into 2. It is 2x is common from here, because e power x is here, e power x is here, you can take this as common, and we get finally 2 into sine of inverse of 3x plus, this is 3 divided by 1 of 9x square, the whole number. That's it. This is the answer of the sine inverse x into e raised to power. And now look at another example. Let we have y equals to x raised to 3 by 2 into tangent inverse of x by 2. So the differentiation by using the UV formula or the product rule, it will be the derivative of this, because taking the power below this and reduce the power of x by 1, 3 by 2 minus 1, and keeping the tangent inverse as it is, x by 2 plus. Now keeping this term as it is, and this is 3 by 2 into the tangent inverse, the tangent inverse derivative 1 by 1 plus x by 2 whole square into the derivative of inner function, which is 1 by 2. So we have the derivative now. You can simply as it simplify this. What is this? It can be written as it is 3 by 2, and then taking its LCM, it will become 1 by 2 x power 1 by 2 into the tangent inverse, writing it is as the same x by 2 and then plus. Writing the 1 by 2 in the denominator, and it is the numerator x power 3 by 2 as this, and writing this in 2 in the denominator, and here 1 plus x square by 4. This is your final answer for this product rule. Therefore, we did 3-4 examples related to the inverse trigonometric function. Now, the last example for this lesson, if we use the trigonometric function, let we take the product of ln of under root of x plus 1 into the cosine inverse of 2x. The product of these two functions, we use the product rule once again, writing the derivative of log. And you know the derivative of logarithm by first of all take this in the numerator like this 1 by this expression under root of x plus 1 into the derivative of this function, which will be 1 by 2, the derivative of x under root 1 by 2, and it will be 1 by 2 minus 1, and the derivative of 1 will be 0. Okay, and keeping the cos inverse as it is, and plus then keeping the ln term as it is, x plus 1, in the finding the derivative of cosine, it is minus 1 by 1 minus 2x whole square by using the formula that we have written in the previous page. Okay, into the derivative of inner function, which is equals to 2. Now we completed the differentiation. Now the last step, we can simplify everything. This is half x raised power minus 1 by 2 and whole divided by under root of x plus 1 and cosine of inverse of 2x. This and plus keeping this as it is under root of x plus 1 and writing this as negative 2 divided by 1 minus 4x square whole under. So this is the final answer. And in this video, I discussed the differentiation, actually the trigonometric inverse functions. You can take more examples from your textbooks or from your past paper. So the practice will make you the perfect. This is the basic rule of the mathematics. Thank you. Thank you, everyone. And Allah Hafiz. Thank you.